This is like one of the simplest ones, right? Actually, we're going to start with the least simple, or the less simple of these two, and then we'll go to the more simple. So let's answer the first question, right? What is the velocity 95 centimeters from the second charge? And then in the second part of the video, I'll answer the second question. Okay. So in the first situation, we got this guy and this guy. This guy is not going to move. This one is fixed. Okay. It's going to stay put. We're going to hold that still, but this guy can move. Okay. And it starts off 45 centimeters away, and if we let it go, it's going to pick up speed. Now, it does have inertia. It's got a mass of 0.0125 kilograms. And by the time it is now then 95 centimeters or 0.95 meters from it, we want to know how fast it's going. Okay, so let's figure that out, right? The potential energy before in this situation, the total energy is just going to be K times Q1 times Q2 over R. Okay, and that's positive because these are both positive charges. That'll be a potential energy. And then the kinetic energy is 0. It's not moving, right? And then afterwards, here it is, and its potential energy. And R here is, I'll call this R1, right? And then afterwards, I'll call this R2, okay? So now afterwards, it's going to be K Q1 Q2 over R2. Now notice that R2 is bigger, which makes this term smaller, right? So some of that energy will be kinetic energy. Okay, and it's the kinetic energy of this guy, since this guy sits still. Now, if they have different masses and they both move, it gets complicated. Okay, if they have the same mass and they both move simultaneously, that's a little easier to deal with, but this guy's going to sit still. So let's figure this out. So K is, of course, 8.99 times 10 to the 9th, okay? So I'm just going to leave it as K. So I'm going to go K times 390 microcoulombs, right? Micros times 10 to the minus 6 times 130 microcoulombs, right? Divided by 0.45 plus 0 is equal to K times 390 microcoulombs times 130 microcoulombs, right? Don't forget to go times 10 to the minus 6, right? And over 0.95 plus 1/2 0.0125 times v squared. And the velocity is the only thing we don't know, okay? So my first step is to go let's see, alpha K times 390, E minus 6 times 130, E minus 6 divided by 0.45. So this potential energy here is plus 0 equals, and then I'm going to do the potential energy at this other one here. Not 0.45, but 0.95. So this is 479.78 plus 1/2 0.0125 v squared. Okay, so that guy, 1012 minus 479. I'm getting that it's 530. We're running out of space. 533.09 is 1/2 0.0125 v squared. Okay, so I'm going to go times 2 divided by 0.0125. And I must take the square root of that. I'm getting 292, so our velocity is, at this point, 292.05 meters per second. Okay? So that's the first part. Let's do the second part. Okay? I'll do that in the next video.